This is the Arduino sketch file that we have worked on last time. The Arduino is at the moment connected, and if we check again, data is at the moment coming in, just like we programmed it last time. Now I will process this value and write a program to save it as a CSV file. Now that processing is ready, and since we will first save it as a CSV file, you need to save it in advance. In my case, I will name it Simple PM 2008 Logo and just save it. Next, in the void setup function, you will need to locate the processing application. On a Windows computer, you can find it in the Documents folder, which is a common location for user files and applications. Similarly, on a Mac, you will also find the processing application in the Documents folder. This folder is typically used for storing user files and applications, ensuring they are easy to manage and access. Make sure to navigate to the correct folder on your operating system to proceed with your setup. Inside processing, I have saved it as the Simple PM 2008 Logo, and it is currently saved as the Simple PM 2008 Logo. This folder has been created, and in this state, the text is currently too small, so I will enlarge the text a bit. Now, in this state, let me first show you how to record something in that CSV file. When writing files in processing, there is a class called PrintWriter. Let's use this and set the output window size to 200 by 200 by 500. I will save the data as a CSV file. The file name is I will use CSV. Next, the frame rate of 10 essentially determines how many times the draw function is executed repeatedly, which ultimately means it operates every frame. By setting this frame rate, you can basically specify how many times the draw function will run in 1 second. In my case, I have set the frame rate to 10. So the draw function will execute 10 times per second. Now, I will try to essentially save the coordinates to a CSV file when I click and move the mouse in the window. This is how it is saved, and then there is a processing function called keyPressed. It is already specified. In this case, when a keyboard key is pressed, it triggers a function that executes. Here, we wait until everything is sent, then stop and exit the program. By doing it this way, when a specific key is pressed, the program will be saved and executed. In this state, if I move the mouse, nothing happens. But if I click or drag, points start to appear. Now, as I move like this, points are being created. And when I press enter, in this state, the program has exited. If you look in this sketch folder, you'll see a data CSV file has been created. If you open it, you will find, in this way, you can see that the coordinates are now saved. Although it appears as an Excel file, it is actually saved in the form of a text file like this. Now that the file has a CSV extension, you can view it in programs like Excel by separating the values with commas. Now, let's try connecting the serial port which is a crucial step in establishing communication between devices. To perform serial communication, you need to add the serial-related library, which contains essential functions and definitions. In the sketch, there is an internal library called serial, which is specifically designed for handling serial communication. By adding this, you will import the serial library, enabling your program to use its functions. At this point, let's declare a variable for the serial port using the serial class, which provides a convenient way to manage serial communication. Then, here we will use the printArray function to print the array data to the console, allowing us to visualize the data being transmitted. When you run this, you will see the available communication ports in the console, which will be displayed. In the case of the Windows operating system, the COM ports will appear. For me, personally, the Arduino is this one, the DTY USB modem. I will copy this information and comment it out, and then I will first connect the serial port. First and foremost, we start on the hardware side of things by carefully entering the code and subsequently creating a TIAs instance. Next, we proceed to input the port name, setting it up precisely like this, and then configure the baud rate to exactly 9600 along with the necessary buffer setting. This is the new line code, specifically the carriage return, new line code, which the Arduino sends as a line break. Based on that, we store and send data in the buffer accordingly. Here, we won't be using the drone, so we'll leave that empty. When we perform serial communication, we use serial events. For the serial event, we originally set up the port red, spring, so that the buffer accumulates based on the line break symbol. Each line sent by the Arduino using that line break symbol will be stored in the message variable. However, there might be parts that are just empty spaces, so I use trim to remove any white space or similar characters, including line breaks. This is the new line code, specifically the carriage return, new line code, which the Arduino sends as a line break. Based on that, we store and send data in the buffer accordingly. Here, we won't be using the drone, so we'll leave that empty. When we perform serial communication, we use serial events. For the serial event, we originally set up the port red spring so that the buffer accumulates based on the line break symbol. Each line sent by the Arduino using that line break symbol will be stored in the message variable. However, there might be parts that are just empty spaces, so I use trim to remove any white space or similar characters, including line breaks. I set it up so that the message quo should not be absolutely null and its length should not be completely empty after being trimmed. Then, I made sure that, ensuring that the printLone message is output to the console and saved to a file. Similarly, I configured it so that pressing a specific key would send everything and then exit. Let's take another look at this code. As you can see, I have now called the serial library and then I declared the printer writer class, an instance for file writing, as well as the serial variable. Here I created the instance related to serial, and when creating the instance, the name of the Arduino port we want to connect to is written here. Initially, you can scan with the printer array to check this, set the baud rate to 9600, and use my port buffer until. To ensure that the buffer includes the carriage return symbol, then, since the size is not needed, I will remove it, and since the frame rate is also not necessary, I will delete that as well. Next, for the output. Since we are working with CSV data, I will remove it to avoid any overlap with the previous one, and I will need to add one more for the header. Here I have carefully organized and compiled this information from the last time we met. When creating the GSB file, I use the output println function to ensure that the first row becomes the header. This step is crucial for organizing the data properly. Ensuring the correct placement of the header is essential for maintaining the structure and readability of the data within the GSB file. I am currently engaged in this task, making sure that everything is set up correctly. Initially, I separated the items using slashes. However, in this instance, you should change the separators to commas. This means that instead of using slashes, you will replace them with commas. To clarify, you need to change it to commas again. For example, if you have a list like item, item 2, item 3, you should change it to item 1, item 2, item 3. And here, once more, change it to commas. Remember, change it to commas. And change it to commas. Empty spaces, empty spaces, empty spaces, empty spaces. I have now added the way to input the header like this in order to easily do it. I mentioned that there is a function called serial event which organizes the code, handles the command, and fills in the incoming data. This function is called when a serial event occurs during serial communication. So, using port read string, I read the data based on the buffer, but since there might be cases where the buffer doesn't fill properly and could have empty values, I first trim the values to clean them up. Then I check if the message is not null and if its length is not 0. If everything is fine, I print it to the console and save it to a file. After that, when I input a key, I wait for all the data to be entered completely before exiting the program. Let me run it once. When executed, there are no errors. In this way, it will now print to the console every 5 seconds, and it will approximately be saved in the CSV file as well. In this state, when I press the key value, for example, right now the program has ended, and as you can see, some values are coming in as garbage values. Normally, if there were no issues, there shouldn't be any outlier values like this. While it can be implemented simply, there are 2 major drawbacks. In this case, it's difficult to verify validity, like with checksums. Of course, you can check the number of commas, but that's very inefficient. Additionally, the data length is too long. For example, if you want to send the number 200, it is sent in ASCII code, which uses 3 bytes. However, 200 could be sent in just 1 byte. So, while the implementation can be a bit erratic, it is quite simple. But because of these issues, in the next session, we will create packets, send them in packet form, and receive them in processing to pass, and accurately verify checksums, just like we did before regarding protocols. Now, we will try putting the data into a CSV. In this session, we received the data sent from Arduino in processing and saved it as a CSV file. As I mentioned earlier, while it is possible to implement this simply, there are a few issues that arise. To address those issues, we will start implementing it in packet form from the next session. So, I will see you next time.